video, we'll be going over Section 1, Part C of the Maryland Envirothon Soils Contest. Part C is focused on soil and site interpretations. So you'll be using what you've learned about the site and the soil to answer questions about the suitability for agricultural uses, urban development, and wildlife habitat, as well as some information that we're going to give you that you'll find on the contest pit information sign. So remember, it's really important that you look back at parts A and B because your answers to those questions will help you make interpretations about how best to use this site. The information sign will be posted outside the contest pit. It's going to give you information about the crop we want to grow at this site, as well as information about the soil nutrient levels, pH, how often the site is subject to ponding or flooding, and the original topsoil thickness. And there might sometimes at specific sites we might provide some additional information. In that case, we'd make sure you're aware of that and how to use it. In this first question, we're asking you to estimate the amount of soil that has eroded from the site. To do this, you're going to use the original topsoil thickness, which we'll give to you, and you'll subtract the current topsoil thickness that's at the site. So the original topsoil thickness you can find on the information sign, and then remember you measured the current topsoil thickness in Part B, Question 2. So you'll subtract the current topsoil thickness from the original, and in this example we had 10 inches of topsoil originally. Currently the topsoil is 6 inches thick, so we know we have 4 inches of soil that's been eroded from the site. So this would be moderate for 3 to 8 inches of the original soil lost. Now, in some instances, the topsoil could become thicker over time, and this might be if you're in a depressional area that soil is being eroded from upslope and is being deposited at the site. So you may see that your current topsoil thickness is actually thicker than the original. So in that case, we would say past soil erosion has been slight, because really there's been no soil loss from the site. In the next question, we're asking you to estimate the potential for future erosion if the soil is cultivated or disturbed. For this question, you're going to be using the slope that you measured in Part A. You measured slope using the clinometer. You're going to use that to determine how likely it is that there will be erosion from the site. Basically, you know, a steeper site, it's more likely that you'll have erosion from there. So if you determine that the site was nearly level, you would say that it had slight potential for future erosion. If it was gently sloping, that would be moderate. And then if you thought it was strongly sloping or steeper, this would indicate that the potential for future erosion is severe. Next question asks you to identify the major limiting factors for agriculture. And so in this question, you'll check all of the limitations that exist at the site, and I'll go through each of them and show you where to find that information from the data you've already collected. So the first that we're looking at is flooding or ponding. And as you can imagine, if a site floods or ponds and you have standing water, that can drown out the crops and make it really difficult to grow crops there. So you'll look at the information sign, and if we've told you that the site floods or ponds occasionally or frequently, you'll mark that as a major limiting factor. Next potential limiting factor we look at is slope. If you're on a really steep site, it can affect the types of crops you can grow. It also means the site could be subject to more erosion. So if you, when you look back at Part A, landscape features, when you measured the slope, if you determined the site was gently sloping or steeper, you would mark that slope was a major limiting factor on the site. Past erosion, we just did that. That was the first question in Part C. If you've had severe erosion in the past, that's a limiting factor because you probably have very little topsoil left. Effective rooting depth. This we looked at in Part B, soil profile features, question 6. So if you thought that there was a layer in the soil that limits root growth, so these could be things like fragipan, bedrock, or horizons with extremely high amounts of sand or gravel, basically a layer that the roots can't penetrate through. If you found one of these limiting layers less than 40 inches below the surface, you would check one of your limiting factors as effective rooting depth. Drainage, remember this is the depth to a seasonally high water table. So we looked at that in Part B in question 5, soil drainage. So you're looking at the depth to redox depletions, and those are the gray colors that form in the soil as a result of wetness. So if you're seeing redox depletions within 40 inches of the soil surface, you would mark that drainage is a potential limitation at this site, basically because if the roots are too wet, it might limit their growth. And remember, we measure the depth, but these correspond to moderately well drained, somewhat poorly drained, and very poorly drained soils. Coarse textures can be a limitation because the soil will be really permeable and water will move through it really quickly, so they can be really droughty. So remember in Part B, we looked at, you evaluated the soil texture for both the topsoil and the subsoil. So if you found that the soil was coarse in both the topsoil and the subsoil, so that would be sand or loamy sand textures, coarse textures, you would mark coarse textures as a major limiting factor. And then at Part A, question 4, you looked at whether or not the surface was very stony or if there were rock outcrops. And if you identified either of those at the site, you would mark that as a limiting factor. Now, if you've gone through all of these limiting factors and none of them appear at your site, you would mark that none, showing that there's no limiting factors for agriculture here. Question 4 is asking you to determine the land capability class of the soil. Land capability classes are a way of grouping and evaluating soils based on the limitations for agriculture and their suitability for agricultural production. The classes go from 1 to 8, and as you increase in class, that indicates that there are more limitations that would affect agricultural production. It's not to say that agricultural production is not possible, just more that there are more limitations. You might have to adapt some of your practices. You might be limited to certain types of crops that would be more suitable to those sites, and it might not be as productive. Generally, classes 1 through 4 we consider suitable for traditional row crops and cultivation, where soils that are in land capability classes 5 through 8 are more suited to permanent vegetation. So to answer this question, you're first going to look at question 3, where we identified the major limiting factors. You may also need to look back at parts A and B to look at things like slope and drainage class to help you determine what the land capability class of your site is. As you go through each of these, you want to be careful reading because you'll notice there's ands and ors. So you want to make sure you're reading it completely and identifying the right combination of limitations for each class. As you go through, basically you'll determine which factors give you the highest land capability class or the most limiting, and that's going to be the one you pick. So you'll see in class 1, these are sites that really have no limiting factors. So in question 3, you checked no, and the site is nearly level. As you go to class 2, these are sites that are gently sloping or moderately well drained or moderately deep. As you go to class 3, these are sites that are strongly sloping or somewhat poorly drained or shallow or have coarse textures. Class 4 are sites that are moderately steep or very poorly drained or occasionally flood. And those are classes 1 through 4. Those again are the ones that would be suitable for row crop agriculture. Now as we get to class 5 and above, these are sites that are more suitable to permanent vegetation. So we're not tilling these sites. And that's because the limitations at these are such that if you started tilling them, you might degrade the soil more quickly. You would have a lot more challenges, getting your equipment in these fields, and you wouldn't get as high of production or yields in these types of soils. So class 5, these are soils that are nearly level and have a very stony surface or rock outcrop, or they're frequently flooded. As we get to class 6, these are sites that are steep, or they're gently sloping through steep and they have that very stony surface or rock outcrop. As we get to class 7, those are soils that are very steep or very shallow, meaning they have bedrock close to the soil surface. And then class 8, these are sites that are really not suitable for agriculture. So it might be swamp, tidal marsh, coastal beaches, areas that have greater than 90% rock outcrop, or urban areas. Question 5 asks you to identify which best management practices are needed at this site. So these are different practices, agricultural practices that help control erosion or improve water quality. So based on the limitations you've identified and the land capability class that you assigned, so you'll be looking at part C where you, earlier in the question right before where you identified land capability class, and you also want to look at drainage class and slope, and you'll determine which practices are needed at this site. You should check all of the ones that apply. Generally, you will end up depending on your site and the specific characteristics, you'll find several that are needed. First practice we'll consider is drainage. And drainage, either through ditching or subsurface tiles, is usually done to lower the water table in soils that are affected by a seasonally high water table. And basically this is done to make it easier to plant crops in the spring and to prevent the crops from getting too wet. So you'll mark drainage as a needed best management practice in sites that are moderately well, somewhat poorly, or very poorly drained, and have a land capability class of less than or equal to 4. So these are sites that are suitable for row crop agriculture based on their land capability class and have a seasonally high water table within the upper 40 inches of the soil surface. Irrigation is used on sites that could be subject to drought, and basic irrigation, we're adding more water to make sure that the crop has enough moisture. So we'll use this practice on sites that are excessively well drained and have a land capability class of less than or equal to 4. Contour farming is when the crop rows are oriented so they follow the slope of the site. And this is to help reduce erosion rather than farming up and down and having rows that can allow soil to be moved quickly down slope. By farming across the slope, that helps slow erosion and loss of soil. So you'll see, we'll use the contour farming practice on sites that are gently sloping and have a land capability class of 2, 3, or 4. At steeper sites, you'll see contour strip cropping used. And this is when different crops are placed in alternating rows to help further reduce erosion off of the site. So we'll use the contour strip cropping practice in strongly sloping or moderately steep soils that also have a land capability class of less than or equal to 4. Grassed waterways are used in drainage ways or swales where water flow is concentrated. And basically the grassed waterway is an area that's permanently vegetated. And by having that permanent vegetation there, it helps to slow down the water that's moving through it. So it helps limit soil erosion because by slowing down the water, it can't carry the soil with it. And it also helps to filter and start cleaning the water before it makes its way to a downstream waterway. So we use the grassed waterway practice on drainage ways or swales that convey concentrated runoff. And so remember, that's one of the landscape positions that you looked at in Part A. So drainage ways or swales that also have a land capability class of less than or equal to 4. No-till farming is recommended for all sites that have a land capability class of less than or equal to 4. And when a farmer is practicing no-till, they actually don't use any tillage in their fields. When they plant their crops, they're planting directly into the residue from the previous year's crop. No-till helps improve soil health. When the soil is disturbed through tillage, it can degrade the structure. So you can go from that nice granular structure that allows good infiltration and water holding capacity. You can go from that granular structure to blocky or platy or even massive structure that can limit water movement and impede some of the biological functioning in the soil. When we till the soil, we also cause organic carbon to be oxidized and lost to the atmosphere. So by not tilling the soil, we also help to maintain organic matter in the soil. By not tilling the soil, we've got that residue left on the surface, and that protective barrier helps to limit erosion off the site because the soil is covered. And that residue and biomass will eventually be decomposed and will add more organic matter back to the soil. Cover crops are a best management practice that's also used for sites with a land capability class of less than or equal to 4. Cover crops are usually planted after the crop is harvested. So in Maryland, this is usually in the fall, and then the cover crop is maintained over the winter. Cover crop, it's not really harvested, it's just used to provide a cover when there's not a traditional crop in the field. Cover crops can help improve water quality because they'll soak up any excess nutrients that are left after the crop is harvested. And so by holding those nutrients, it prevents them from being leached out of the soil and moving to downstream waters. And then when the cover crop is killed in the spring, all that organic matter, that plant biomass, is returned to the soil. So we're adding organic matter, but also all those nutrients that they were tying up and holding throughout the winter. So that can help reduce fertilizer needs, and it helps maintain our downstream water quality. Cover crops also provide soil health benefits. They're adding organic matter, as I mentioned. They're also providing living organic matter throughout the winter. So the microbes that are living in the soil, they'll have a continuous food source because they've got these living roots all through the winter. And then lastly, cover crops can provide some benefits to help limit erosion because you've got that protective surface that'll be over the, covering the soil throughout the winter rather than leaving the soil bare. So again, cover crops, that best management practice, will use that on all sites that have a land capability class of less than or equal to 4. The last practice we'll consider is permanent vegetation. And this practice is used for sites that have a land capability class of 5, 6, 7, or 8. So remember, at these higher land capability classes, the site is it could be steep. There might be a lot of rocks, and it's not well suited for row crop agriculture. And it's really best that these sites, we want to have permanent vegetation. We don't want to be tilling it. Partly, it could be subject to really high erosion rates. It may also have a lot of rocks, or because of the steepness, it's difficult to get agricultural equipment in there. So permanent vegetation, it could be, like in this picture, a pasture or a hayfield. It may also be woods or wetland, depending on the characteristics of the site. The next question is asking if the soil is hydric, meaning is it a wetland soil? So you'll look back again at the drainage class. If the soil is poorly drained or very poorly drained, meaning that you have a water table in the upper 10 inches of the soil or even possibly ponding on the surface, this is a hydric soil or a wetland soil, so you would check yes. Question 7 asks if the soil is prime farmland. Prime farmland refers to soils that have land capability class 1 or 2. So you'd look back to the land capability class that you determined for the site, and if it fits into 1 or 2, then you would mark yes, that this soil is prime farmland. And really that just indicates that being class 1 or 2, there's very few limitations, and it would be a productive site for agriculture. The next sets of questions, we're going to be looking at soil health. First question, you're going to use, we're going to look at the color of the soil to determine the soil health. Now remember, when a soil has a lot of organic matter and biological activity, it's usually darker in color. So you'll evaluate the soil health and determine it to be good, fair, or poor based on the color. In part B, question 11, you had to determine the color using the Munsell soil color book. And so you'll use that color notation to put it into one of these categories. When we're saying it's good, that means it's dark in color, so it would have a value of less than or equal to 3 and a chroma of less than or equal to 3. So it would be these chips down at the bottom. If the soil is, if we're saying it's in poor soil health based on the color, it's probably very low in organic matter, the value would be greater than 4 and the chroma would be greater than 4. And if the color falls somewhere in the middle here, that's what we would put in the fair category. The next question is looking at compaction. Now remember in question 12 of part B, we asked you to use the pin flag to determine if the topsoil layer was potentially compacted. So you'll look back, look at how if you thought there was much compaction there, meaning it was difficult to push the wire flag in, or if it went in really easily, indicating that there was very little compaction. So then you'll just check the appropriate description, good, meaning little to no root restrictions, to poor, where the roots may have to grow laterally because there's so much compaction in the soil. And our final soil health question is looking at the structure of the soil. Remember in part B, we asked you about the topsoil structure. So then you'll use that structure to evaluate the health of the soil. So we talked about with the different structures, usually when we have a lot of organic activity and organic matter in the soil will get a granular form, kind of looking like cottage cheese. It'll be very soft and crumbly, and there will be a lot of fine roots. That would be an indicator of good soil health. Whereas if the soil is more blocky and firmer, that would be fair. And then if the soil structure is single grain, massive, or platy, hard to break apart, you don't see a lot of roots, that would be an example of poor soil health. Question 11, we're asking you to determine what the soil nutrient needs are for this soil. So on the information sign, we're going to give you information about the crop that's going to be grown, the pH, and the magnesium, phosphorus, and potassium levels in the soil. And from that, you'll determine what soil nutrient or fertilizers or amendments that are needed at this site. And you will check all of the ones that are needed. So to determine if lime is needed, lime is used to raise the pH of a soil. So you'll look at the pH. If the pH is less than 6.5, you'll need to add lime to help bring that pH up because it's a little too acidic for crop growth. So in this example, the soil had a pH of 5.9, so this is a site where we would want to add lime. Nitrogen, you'll look at the crop that's going to be grown to determine if nitrogen fertilizer is needed. Some crops are able to fix their own nitrogen, so they can take nitrogen out of the atmosphere, and so we don't need to add nitrogen as a fertilizer. And these crops are legumes, so that includes soybeans, peas, clover, and alfalfa. So if the crop that's going to be grown is a legume, then you don't need to add nitrogen fertilizer. But if it's not a legume, such as here we want to grow corn, then we'll need to add nitrogen fertilizer at this site. And then we're asking you to look at the nutrient levels of magnesium, phosphorus, and potash or potassium. For each of these, if the soil test levels are very low, low, or medium, that means there's not enough of those nutrients in the soil that fertilizer will need to be added. If the levels are high or very high, then you don't need to add those fertilizers. So in this example, since our pH is 5.9, we'll want to add lime. Since we're growing corn, which is not a legume, we'll need to add nitrogen. And then looking at our nutrients, our magnesium levels are low, so we'll want to add magnesium fertilizer. The phosphate levels are high, so we don't need to add that. And our potash or potassium levels are medium, so we'll want to add potassium fertilizer. The next set of questions are focused on the soil and site suitability for urban uses. So question 12 is looking at suitability for septic tank absorption fields. And basically you're going to be looking at a number of different properties. For this one you'll look at slope, flooding frequency, depth to bedrock, depth to redox features, and subsoil permeability. And you'll use the most limiting soil property to determine your overall suitability. So this can be a little tricky, but what I'd recommend is looking at each of these properties and determining where your site fits. And then you can use whatever the most limiting one is to determine your overall suitability. So we'll go through this. So for slope, we'll look back in part A where we determine the slope. And for septic tanks, as your site gets more steep, that becomes a more limiting factor. Flooding, you'll get that from the contest pit. Obviously, if you've got a septic tank, or if you want to put in a septic tank, you don't want a site to be flooding because that would have some really bad implications for water quality. Depth to bedrock, remember we got that in part B where you looked, you determined if there was bedrock within the top 60 inches. So based on your bedrock, if you have bedrock close to the surface, it makes it more difficult to put in a septic tank. Redox feature, so we're looking at the drainage class, how close to the surface the seasonally high water table is. And then subsoil permeability, that's how quickly water moves through the soil. So that's question 9 in B. So how quickly does water move through the subsoil? And as it moves more slowly, that becomes a greater limitation for your septic tank. So if you go through each of these and determine where they all fit, that you'll use the most limiting one. So you can see here, our most limiting soil property was the depth to redox features. Seasonally high water table is within 40 inches of the soil surface. So the suitability of this site for a septic tank would be severe. You always look for the most limiting property, and that gives you your overall class. Now again, these suitabilities don't say that you can't put in a septic tank at this site. It just means there's more limitations, so you might have to use a slightly different system, you might have to make some modifications, or it could become more expensive. Next question, we'll be looking at the site suitability for lawns. So very similar to the last question, Soil properties you'll be looking at are slope, soil surface texture, rock fragments in or on the surface, past erosion, and the depth to redox depletions. If you think about, a good site for a lawn, you don't want something that's very steep. You don't want a lot of rocks on the surface because that can make it difficult to mow the lawn. You don't want it to be a site that's too wet, which if it had a high water table or if it's not very permeable and it can pond water, that would make your lawn wet. So again, go through each of these properties, determine what your most limiting feature is, and then that'll determine your overall suitability. And just a suggestion when you're doing this, we only grade you on what you mark for the overall suitability, but it's helpful to circle in each of these how limiting each of the soil properties are. That makes it easier for you to check your work or for one of your teammates to check your work and understand how you determine the overall suitability. Question 14, you're looking at the suitability for dwellings with basements. So a basement for a home. The properties you'll be looking at are slope, flooding, depth to redox depletions, again, our seasonally high water table, and the depth to bedrock. Lastly, we have a question about wildlife suitability. So we want you to determine which wildlife habitat is the soil best suited for. So your options are wetland wildlife or upland wildlife. So in part C, question 6, we asked you if the soil was a hydric soil or if it was a wetland soil. So if you marked that yes, this is a wetland, it would be most suited for wetland wildlife. Or if you marked that it was not a wetland, then it would be most suited for upland wildlife. That's the end of part C. Just once again, one final reminder, be sure when you're completing part C that you're going back and you're looking and checking against your answers from parts A and B and on the information on the contest pit sign to make sure that you're using the correct information when you're making your interpretations about the site. Good luck.